Now this little thing is a spring.
Now I think it could be argued that springs are one of the most important inventions of humankind, right up there with the wheel, the washing machine, sliced bread. We think of springs mostly like this bent bit of metal, but a spring is any elastic material with rigidity that can return to its shape after being compressed or extended. And what that means is springs can store energy. The bow is an example of a non-metal spring that's been around with us for something like 70,000 years and could be seen as fundamental to our survival as a species. But of course, there are lots of different kinds of springs, and we can classify them in terms of their type, in which case we get things like V-springs, coil springs, leaf springs, involute springs, all kinds of different types. Another way of looking at them is in terms of their physics or the load applied to them. And perhaps the three most important ones are going to be compression springs, extension springs, and then torsion springs. Now, a compression spring usually has an open structure. You squeeze it or compress it, and when you let go, of course, it goes back to its original shape. An extension spring is usually a much closed structure. You put a tension on it or extend it, let it go, goes back to its original shape. A torsion spring is where you twist it round, and perhaps some of the most infamous uses of this were in the Roman artillery, in things like the ballista, which was used for firing projectile weapons, or the onager, which was used for battering down defences with stone or metal balls. And it was often made of timber and sinew or hair or rope, and they could store a huge amount of energy because these were very destructive machines. So whatever the physics and whatever the type of spring, they have the same job, and that is to store energy for later release. So springs don't have to be metal. They come in a huge variety of forms, and of course the filament in 3D printers has all the qualities of a spring. That is, it has elasticity and it has rigidity. Of course, this isn't something that's escaped people. You find 3D printed springs all over the place, from desktop catapults to wind-up clockwork cars, clocks themselves, and of course the famous print-in-place Nerf gun. But the spring doesn't have to be at the centre of attention. This ability to store energy and release it later can be used even in the humblest of machines, even in something as everyday as the latch. So the latch does a really simple job. All it really does is keep things closed, but it's such a fundamental task that you find latches in millions of designs, and they're absolutely everywhere. They're a bit like hinges and ball bearings. We don't really think about them, but they're essential to what we want to do. And of course, we can upgrade the simple latch by adding a few springs. And if we add a few springs, we can turn it from manual to automatic. So we need to create a spring. To make a spring, start with this semi-cylinder here and put it onto the workspace. Now we want to rotate it into an orientation that's easy for us to work with, and to do that we use these rotation handles. If you click on the handle and move to the outside, you'll be able to move it by 1 or 2 degrees. If you keep it on the inside, it will jump by 22 degrees per jump. So we'll put that at 90. And then we need to bring it level to the base. And then I want it that direction, so let's swivel it round by 90 as well. And that gives it an orientation that I'm going to find easy to work with. Now, if we click on it, we can see the size. It's 20 by 20. It's a semi-cylinder, so it's 10. Let's make that a centimetre high, so 10 millimetres, and a centimetre deep, so 10 millimetres. Then it's not a semicircle, so let's change that to 5, and we get our semi-cylinder. Now, to make this part of the spring, we need to thin it out as a leaf. So if we just go into that, copy it, and then we can change this to 8, which gives us a millimetre all the way around once we centre it. And this one to 4. Make it a hole, highlight it, use the centre key to centre it to the centre of the cylinder, and to the edge of the cylinder right there. Now if we group those together, we get ourselves a little band. We want the actual breadth of the spring as well, and so we take a cube primitive, make it 1 millimetre by 10, because that's how tall it was, remember, and we'll leave it at 20. Now we need to line it up to this. So we can do that just by highlighting the two of them, hit the line up key, click on the semi-cylinder, line it to that edge. Now if we jump down to that, we can use the work plane tool to create a work plane right there, and then we can drop that onto that work plane, which will line it up. Now if we group those, we have the basics of our spring. All we need to do is repeat that. So if we click on it and copy it, then we can mirror it in that direction. And remember, it's 10 deep, so we need to move it so that it lines up. There we go. And then we need to move it to the right so it's lined up there. Now we can just repeat that. And it will build our spring to any size we want. Obviously group it, and we can print it.
And then, of course, we printed it out. Now, when we've printed it out, we print it that way. And what that means is that the print will follow that snaking line, and the grain won't be somewhere like here, in which case it'll snap. But when it follows it that way around, we get a pretty good compression spring. There is a spring primitive available in Tinkercad. If you go to the search bar and type in spring, it'll pull one up for you. But knowing how to do it this way means you can make this spring to any dimensions that you actually want. And as you can see, this one's actually 40mm by 10mm instead of the 20mm that we did. So this is a much larger spring.
You can change other dimensions on this, obviously. I mean, if you make this thicker or thinner, you'll change the stiffness of the spring. The thicker it is, the stiffer the spring. And of course, having it like this way means that we can add bits onto this as part of the model. Now, in order to make this a latch, of course, we need some other bits.
And here's the other bits we need. Now, these are just squares and triangles put together and added onto that original spring that we drew, and I've created two of them. I've also created this slide for those to move in and out of because they drop into there. Then I've created this, which is our lock. Now, it's a trapezoid with rounded corners, and what happens is if I push the trapezoid in there, it starts to hit a little bit of resistance where we're compressing the springs continue to get compressed until they snap in place, and hey presto, we have a latch. Now, there's a minimum of utility to that, of course, because to release it, I have to pick it up like that. What we really want to do is move those springs back again to release the catch and de-latch this.
To do that, I created this push bar with the hole in the centre, a couple of prongs on the end, and a little indentation either side so that you can hold it.
The way that it works is that push bar goes in the centre of the rod there, passing through the centre. It meets these two lock bars and it pushes the lock bars out of the way against the springs. And it'll do that until it pushes the lock bars far enough away that the lock itself can come back out of the locking position, and then we can pull it out and we can unlock it. Now, of course, I'm having to do a lot of manual hold this, hold that, but that's what this one's for. This extra spring actually goes in the bottom there. So when we're putting the lock in, it pushes against this extra spring. Then when we push this one, it's also pushing against this compression spring until there, and you can see it now forces it past its position, and we can just withdraw it. So these springs make this all automatic. The only thing I need to do now is put a few guides. This is a guide for locking it. And that fits in that way so that everything pushes there. You might have noticed the little lips there. So when I push that, it'll do that job. We've got a top. We've got a couple of little guides to go on here because these guides, when they go on, are bigger than that central push bar. So it's quite difficult to push the push bar, which it should be, and I'll explain that in a minute. Now we can glue all of this together. So these two plates have been glued onto there. There's a couple of marker notches for them. That bar that we just talked about slides in there, and you can see the indentations where you have to go around to push it. This central lock then slides in there. and there's a little button at the end that glues onto that end there, and that's that section completed. This section's had the springs now glued in place at the back to stop them flapping around, and then we can glue the top on. Now if we take hold of that and push it in as we would a lock, then nothing happens, it won't lock. So we push it in as a lock and it stays that way open until we push that button. You hear that click? Now if we pull it, it's actually locked. It won't now come away unless we take hold of those two slides in the bottom there and push that till it clicks, and then we can actually withdraw the lock. Yeah, I think that's pretty awesome actually. If you slide it in place, then nothing at all. It won't lock until you press that button. You press that button and now the whole thing will stay locked until you slide that bar in there, and then the whole thing will come out. You find latch mechanisms like this in things like carbonic releases, and there are latch mechanisms that hold your bumpers in place. You also find it in card readers. I personally think it would make a great child lock, because as you saw, getting to these little indentations is a little bit challenging. So there's a lot of uses for a mechanism like that I can see. I hope you enjoyed the video. Thank you very much for watching. I will of course put these files onto Thingiverse should anybody want to play around with them or print them off. And please do remember to like and subscribe.